Physics is about exploring the universe. We ask big questions about how things work. But with great questions comes great responsibility. Safety is paramount. We must protect ourselves, others, and our environment. Before we even touch an experiment, we think about safety. What could go wrong? How can we prevent accidents? We wear goggles to protect our eyes. We handle chemicals with care, wearing gloves and masks if needed. Thinking ahead is key. We never conduct experiments alone. Someone should always be there to help if needed. We also dispose of materials properly. Some chemicals can harm the environment if not disposed of correctly. Safety isn't just about rules, it's about respect. Respect for ourselves, our colleagues, and our planet. By prioritizing safety, we ensure that scientific exploration is both exciting and responsible. Physics relies on precise measurements. We quantify the world around us. To do this, we use specific tools and techniques. To measure mass, we use balances. These come in different forms, but all compare an unknown mass to a known standard. Time is measured with clocks and stopwatches. Length? We use rulers, meter sticks, or even lasers for greater accuracy. Volume is a bit trickier. For regular shapes, it's length times width times height. But for irregular objects, we can use displacement methods. We submerge the object in water and measure how much water is pushed aside. Temperature is measured with thermometers, and force is measured with a spring scale, which measures how much a spring stretches when a force is applied. Electric current is measured with ammeters, and electric potential difference or voltage is measured with voltmeters. Angles are measured with protractors, and the intensity of sound or light can be measured with specialized sensors. If physics is about understanding the universe, math is the language it speaks. Math helps us describe relationships and make predictions. Proportionality is a key concept. It tells us how one quantity changes in relation to another. For example, the distance an object falls is proportional to the square of the time it falls. We also use math to calculate changes. Percentage change tells us how much a quantity has increased or decreased. Error and uncertainty calculations help us understand the limitations of our measurements. Physics often deals with quantities that have both size and direction. These are called vectors. Velocity, for example, is a vector because it tells us both how fast an object is moving and in what direction. We can add and subtract vectors and find their components. Graphs are powerful tools in physics. They allow us to visualize relationships between variables. One common type is a line graph. We use these to show how one variable changes as we vary another. The slope of the line tells us about the relationship between the variables. For example, a steep slope on a distance time graph indicates a high speed. Bar graphs are useful for comparing different categories. For example, we might use a bar graph to compare the speeds of different animals. Pie charts show how a whole is divided into parts. For example, a pie chart could represent the composition of the Earth's atmosphere. By carefully plotting our data and choosing the right type of graph, we can gain insights into the physical world. Graphs help us see patterns, make predictions, and communicate our findings effectively.